Okay, so for chapter 3, okay, so actually not too much the content, okay, but yeah, we'll cover some kind of most difficult yeah, knowledge we'll learn in organic chemistry 2, okay, organic chemistry 1, okay. So first about yeah, molecular orbital, okay. So we already learned the yeah, use Lewis structure or kind of line angle structure show the yeah, organic molecular structures, okay. But yeah, for some situations, okay, so that's actually kind of you cannot explain everything, cannot show how the reaction happened, okay. So especially like the yeah, conjugated system. And then we have to learn, yeah, use another way to explain it, okay. So that's here come to molecular orbitals. So to learn molecular orbital, we first need to learn yeah, atomic orbital, okay. And then based on that, okay, so yeah, we will learn yeah, the yeah, molecular orbitals, okay. So yeah, in this part, molecular orbital, okay, or yeah, BITLs. And we'll also learn the yeah, hybridization, okay. So yeah, what's the hybrid of certain carbon or some kind of oxygen, okay? sp2, sp3, sp, okay? So those we'll learn in this part, okay? And then last part, okay, also the most difficult part is kind of yeah, resonance, okay? Okay. So the resonance, yeah, we will put a lot of time on it, okay, because the yeah, resonance kind of each time, yeah, yeah, when we come kind of resonance, okay, a lot of students get confused, okay, so yeah. And another hard part is kind of yeah, the hybridization, okay, but yeah, I guess yeah, you guys already learned the organic chemistry, not organic chemistry, general chemistry, okay, so yeah, little bit of coverage about this, okay, so. Right, and for yeah, my lecture, okay, so yeah, we'll do the hard part first, okay. So we'll try to learn how to draw the resonance structure, okay. And because later, okay, so yeah, when we come to kind of multiple orbitals, okay, we'll use some knowledge, yeah, from yeah, resonance structure, okay. All right. So here I want you guys a little bit of focus on, okay, because yeah, now I will talk something of one of the most difficult part for the organic chemistry, okay, resonance, okay. Right, and for resonance, okay, so yeah, we already talked a little bit in the yeah, chapter 1, okay. So yeah, for sometimes, okay, so yeah, for one yeah, 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 actual structure, okay, you can show yeah, yeah, more than one yeah, Lewis structures, okay. Actually, yeah, now yeah, yeah, Lewis structure represent kind of yeah, the actual structures, okay. And those yeah, Lewis structure are different only yeah, yeah, by the position of yeah, electrons, okay. So example yeah, show there, okay, so yeah, for the yeah, CO3 minus 2, okay. All right, so for this one, okay, so you actually kind of yeah, draw three the yeah, Lewis structures, okay. All right, so we add lone pair on, okay, and also charge on. So for this Lewis structure, I want to put it into the yeah, bracket, okay, so because the yeah, it will be easier for me to show the movement of electrons. All right, okay. So yeah, all these three actually kind of right Lewis structure for the yeah, carbonate, okay, CO3 minus 2, okay. So only difference is kind of actually the yeah, electron yeah, the locations, okay, right. For the first one, okay, so bottom two oxygen have we are the yeah, lone pair electrons, okay, negative charge on it, okay. And then what you can do is kind of the yeah, shift here, for example, okay, so this pair of lone electrons, okay, to yeah, the yeah, oxygen and carbon, okay, build up actual kind of yeah, pi bond, okay, CC double bond, okay, CO double bond, okay. And then meanwhile, okay, shift here the yeah, share electrons, pi bond electrons between the yeah, top oxygen and carbon, okay, all give to yeah, the oxygen here, okay. So then we generate kind of yeah, the resonance 2, okay. Right, so that's yeah, the yeah, original kind of yeah, the yeah, pi bond electrons, okay. this is the original kind of the lone pair electron from oxygen. Okay, so now goes here. Okay, right. So we connect these two by some kind of double-headed arrow. Okay, right. Okay, so you can do the similar thing. Okay, so for the middle one. Okay, so we shift here now the lone pair electrons on the right oxygens. Okay. And shift between the carbon oxygen build up the pi bond. Okay, and then we shift these two electrons back to the left oxygen. Okay, and then we get the lone pair electrons here, and then pi bond electron here. Okay, right. Actually you can do it here the more. Okay, so for example you can shift lone pair electrons on the top oxygen. Okay. Goes down, build the pi bond here, and then shift this pair back to this oxygen. Okay, and then you get to the first resonance structure. Okay, so you can see here. Okay, so pretty much just the shift pi electrons, the lone pair electrons between all these the 4 atoms. Okay, and so for the actual structure. Okay, it's just the kind of hybrid of all these the resonance structure, also called resonance contributors. Okay, and for the two resonance structure. Okay, so we use double-headed arrow. Okay, connect them. Okay, and then use curved arrow. Okay, that's curved arrow. Okay, show the movement of the electrons. Okay, something like this. Okay, show the movement of electrons. Okay, right. So how do we draw the resonance structure? Okay, so as already said, kind of use curved arrow to show the movement of pair of the electrons. Okay, 2 electrons. Okay, and so you need give indication. Okay, so where these 2 electrons goes. Okay, so that means the arrows. Okay, should start here where the electron currently located. Okay, so normally kind of the pi bond or kind of lone pair electrons. Okay, so example showed here. Okay, right. So now let's see where it can start. Okay, so let's see where it start. Okay, and also need to show it's kind of where to go. Okay, so for example these lone pair electrons now go to kind of between the carbon and those oxygen build up actual kind of pi bond. Okay, this pair. Okay, goes to kind of oxygen. Okay, give you kind of actual lone pair electrons. Okay, where it's go and where's the end. Okay, right. And another example showed here. Okay, pretty good one. Okay, so just use the line angle structures. Okay. Right. Okay, so we have the pi bond electrons here. Okay, and then these 2 okay can shift to the between the middle carbon and the right carbons. Okay, and then you get kind of the new pi bond. Okay. Right, so new pi bond electrons. Okay. You need start with where the electron original located. Okay, and then point to where the electron will move to. Okay. And so one case in keep in mind. Okay, one case in keep in mind. Okay, you can never break up kind of a single bond. Okay, so for example, okay, for this guy. Okay, right, so that's a single bond. Okay, so you cannot tell the move electrons. Okay, from a single bond. Okay, move away from. So for example, I want to move this electron to the terminal carbon. That's wrong. Okay, because this carbon and this carbon only connect by this single bond. Okay, so if you move away, break up the molecule. Okay, so that won't be original molecule anymore. Okay, so that's something to keep in mind. Okay, and the second thing, some students maybe already noticed. Okay, so the formal charge location kind of changed. Okay, so so the positive and negative, okay, negative, okay, negative, okay, and then positive here and not positive here. Okay. So the reason for that kind of when you move the electron around. Okay, so some atom will lose electrons, some atom will gain electrons. Okay, definitely cause the charge the change. Okay, so so in this case when you draw Lewis structures. Okay, make sure that you label the charge. Okay, label the charge. Okay? Track where the charge goes. Okay, so that's the common mistake by students. Okay, right, forgot to label the formal charge. Okay, so and give you another example. Okay, so for example, this guy, okay. All right, so we have this new compound, okay, and then you can do the Raster structure like this, okay. So shift pi bond, okay, electrons all give to your oxygen. All right, so now original the both carbon, oxygen are neutral, okay, but the shared reaction between these two guys, okay, all give to oxygen. Oxygen get one extra electrons, okay, that's become negative charge, and then carbon kind of lose one electrons, okay, become positive charge, okay. So you need to track where their charge goes, okay. And so you can do the formal charge calculation. That's we learned kind of equals kind of one electron minus the half shared electron minus all the kind of unshared electrons, okay. But at current stage, okay, you should able to quickly tell what's the formal charge for individual atoms, okay, depending how many kind of lone pair electrons and how many bonds on the atoms, okay. So that you have to know how to do it, okay. All right, okay. So now we'll learn totally 5 types of the resonance kind of interaction. How to the 5 kind of resonance kind of the shift, okay. Right. Okay. So use a new page. Right, and then the first kind of the resonance structure is the electron kind of pair next to the pi bond, okay. All right. So next to means these two guys connect by single bond, okay. Right. To give you one example, you know what's happening, okay. So all right. So we have this structure, okay. So this molecule, okay, and there's a negative charge out here, okay. Right. So lone pair electrons, okay, electron pairs next to pi bond, okay. So that's pi bond, okay. So you see kind of these two guys connect by single bond, okay. Right. Lone pair electron next pi bond, okay. Right. And then for this situation, okay, you need to push electron twice, okay. So first time kind of the lone pair electron go to between carbon oxygen, build up kind of actual pi bond, and then next kind of this pi bond, okay, electron all give to your right oxygen, okay. And then you draw kind of a new resonance structure. Right. So now these two electrons actually from the original kind of shared the pi bond, okay, and then this pi bond actually kind of electron from the original kind of the lone pair electrons, okay. Right. So that's the first situation, okay. And then second situation is the empty p orbital next to the pi bond, okay. So next to means these two guys connect by still single bond, okay. All right. Okay, so give you one example, okay. So actually we still use the same thing here, okay. So CH2, okay. CH2. Right. So empty p also normally happen some atom has a positive charge, or some atom kind of actually the right definition kind of some atom has less than 80 electrons, okay. So so now not full octet rule, they have kind of empty orbitals, okay. So that's like this carbon, okay. Right. So that's the empty p orbital, okay. And then next to pi bond, okay. So this is the pi bond. All right, okay. So still connect by single bond, okay. Right, and then you can do this kind of shift, okay. So this the shared the pi electrons now shift to here, okay. Right. Give you kind of a new pi bond. And then actually move the color pen, show the new pi bond. Right. Okay, keep in mind, okay, you need to track the positive charge, okay. So positive charge now is here. Okay, someone ask question. Oh yeah, you are right. Okay. There's the next charge on this oxygen. Yeah, that's right. Okay, forgot. Okay, sorry about that. Okay. So the yeah, you have to keep the charge. Okay, track. Okay, so that should be here. Okay. Yeah, that's right. Okay. So yeah, always keep track of the yeah charge. Okay, label the charge. Okay. So yeah, originally the yeah, top oxygen has a negative charge. Okay, and then now the bottom oxygen has kind of a negative charge. Okay. Similar thing for the bottom one. Okay, so original kind of yeah, the last carbon has the positive charge. Okay, but now it's gain one electron. Okay, and then yeah the yeah last carbon lose one electron become positive charge. Okay, so yeah, overall charge should be same. Okay, so it should be same. Right. Right. Thank you for catch up. Right. 3. So that's the yeah electron pairs next to empty p orbital. Okay. Okay, so yeah, this one case, okay, one example, something like this. Okay. Right. So next two means kind of yeah, yeah, still connect by single bond. Okay, so empty p orbital and then lone pair electrons, single bond here. Okay. All right. Okay, so yeah, electron, yeah, the lone pairs, okay, empty orbital, okay, empty p orbital, okay. All right, so you can do is kind of yeah, yeah, lone pair electrons fill in yeah, yeah, empty p orbitals, okay, and build up kind of yeah, the pi bond, okay. All right, something like this, okay. And so this time, okay, so keep in mind, okay, so yeah, yeah, the charge will become on the yeah, oxygen, okay, because the original oxygen neutral now have to share one pair of electrons with the this red carbon, okay, red carbon become neutral, okay, yeah. Okay. So that's 3, okay, so maybe let me see, okay, so okay, to put the all together, okay, so I just yeah put here the fourth one here, okay. The fourth one kind of the yeah, pi bond between the two atoms with different here the electronegativity. Okay. Make sure that yeah these two atoms have be different, okay, and then different electronegativity. Okay. So yeah, is different electronegativity. So I use yeah yin represent kind of yeah electronegativity. Right. Example yeah the yeah okay. So yeah I show this one. Okay. Right. We have one pi bond between the carbon and nitrogen. Okay. And so they have different electronegativity. So in this case, yeah, always keep in mind, okay, so yeah, yeah, share electrons, okay, so yeah, share the pi bond, okay, can shift to yeah, yeah, higher electronegativity, yeah, atom, okay, do this one, okay, because this one has higher electron, easy to grab the other electrons, okay, so never go to kind of yeah reverse order, okay. So for this situation, okay, so yeah, yeah, normally we generate kind of yeah charge separation. Right, so now the nitrogen has yeah, yeah actual lone pair electrons, okay, and then charge separation, okay, so both the very beginning, the yeah, nitrogen carbon is kind of yeah, neutral, okay, but yeah, once you shift the electrons, okay, so yeah, carbon miss one electron, become positive charge, and then nitrogen gain one electron, became kind of yeah, negative charge, okay, so that's yeah, but overall charge is still the same, okay. And then yeah, the fifth situation, okay, just kind of yeah, circular circle of your pi bond, okay. So this yeah, situation normally happen, yeah, you have kind of the cyclic yeah, structure, okay. And then yeah, in this cyclic structure, there's yeah, the alternating and the double bond, single bond, okay. So yeah, so pretty much aromatic compound, okay. So that's yeah, yeah, we learn in chapter 2, okay. Okay, alternating double bond, single bond, double bond, single bond. Okay, so all around. Okay, okay, and then you can do this kind of shift. Right, so the pi bond shift here between the single bond and then do the kind of just a circular way. Okay? Right, all around, and then original the double bond position become single bond, and the original the single bond position become double bond. So this one actually kind of pretty easy, not hard. Okay. Right. So that's all the 5 possible the resonance structure, resonance kind of interaction. Okay. In our textbook, there's another one called the single electron the resonance. Okay. So those are only for reticle. So we won't study it here. Okay. So we'll start it in the reticle chapter, probably in organic chemistry 2. Okay. And in our textbook, okay, don't have the third one. Okay. Electron pairs next to empty p orbital. Okay, so don't have this one. Right. So this is kind of actually also one types of resonance structure. Make sure when you study the textbook, okay, so make sure you add this one on. Right. And so for the reality, okay, so in the exam quiz, okay, there's possibility for the combination of resonance type. Okay, so if I give you one structure, okay, so there's kind of more than one of these 5 types of resonance structure you can draw. Okay, and give you one example. Okay, need to be higher. Okay, for example, this guy, and so first we find kind of that's pi bond connect pi 2 different atoms with their different electronegativity. Okay. So in this case here, you can shift the pi bond to the high electronegativity atom. Okay. So that's do this. Oxygen gain 1 electrons and become negative charge, and then carbon lose 1 electrons, become positive charge. And you should immediately find that's the empty p orbital next to pi bond. Okay, so that's the here empty p orbital next to pi bond. Okay, so the second degree, and then you can draw another resonance structure. Okay, so right. So now the new pi bond position on these 2 carbon in the middle. And then the positive charge now shift to the terminal carbon here. Okay, so that's the make sure you track the charge chain. Okay, charge chains. All right. Okay, so that's the 5 types of the resonance structure. Okay, and so there are some kind of rules. Okay, for the drawing the resonance structure. Okay, the first. Okay, so you can only move electrons. Okay, so you build a new pi bond. Okay, or kind of new lone pair electrons, whatever. Okay, but you never move atoms. Okay, so if you move atom, okay, so that won't be same molecule anymore. Okay, so example showed here. Okay, so let's say last structure. Okay, has the hydrogen on the bottom, oxygen, but the right one is kind of hydrogen move to the top oxygen. That's the not the resonance structure. Okay, so because break up the bond. Okay, and then the break up single bond. Like I said, okay, you cannot break up single bond. Okay, and then move the atom. Okay, so that's wrong. Okay, so that's just something to keep in mind. Okay, so when you draw the resonance structure, okay, the base structure. Okay, so the arrangement of all the atoms still same. Okay, so include hydrogen. Okay, everything same. Okay, only thing changed are the movement of electrons. Okay, pi bond, lone pair electrons, empty p orbital, something like this. Okay, so all right, and second thing is after you draw the resonance structure, okay, make you double check it. Okay, and then total Warling selector number should be same as the original structure. Okay, and total charge also be same. Okay, so example showed here. So for this original structure, totally 4 bonds. Okay, so 1 double bond, 2 single bond. Okay, and then 2 lone pair electrons, totally 12 pi electrons. Okay, 12 valence electron. Okay, we ignore the CH bond. Okay, so there's some CH bond. Okay, and so after you draw the resonance structure, okay, become kind of 3 single bond, and then 3 lone pair electrons, still totally 12 valence electrons, okay, 12 valence. And total charge, okay, left molecule is the neutral, and right one, although there are charge separation, okay, so but the total charge is still there, okay. So that's make sure you check it, okay. And like I said, kind of more important, kind of you need show the formal charge, okay. So movement, okay. So sometimes you build a new bond, okay, and then shift the lone pair electrons, okay. The formal charge will change, okay. And you can do the formal charge calculation, but the easy way is kind of just know where the electron goes, okay. So if the atom lose 1 electrons, that will be +1, okay. If electron the atom gain 1 electrons, okay, it will be -1, okay. So that's easier. All right, and then the third rule is never exceed octet rule for the second row elements, okay. And so example showed here, okay. So some students kind of try to shift the lone pair electron on this oxygen between between the nitrogen and also oxygen build out a pi bond, okay. So that would be wrong, okay, because once you shift to here, okay, so the nitrogen will have has more than the 80 electrons, okay, and then that's break up octet rule. That's wrong, okay. And the second one, the similar situation, okay. So second one maybe because we just start to learn the line angle structure, okay. So sometimes the students forgot how many hydrogen attached with the carbon, okay. So that's sometimes they show this kind of mistake, okay. All right. So for this carbon, okay, there are still the 2 hydrogen attached to it, okay. Just kind of when we draw the line angle structure, we ignore it, okay. And so if you shift the electron like this, okay, so so that's your break up octet rule, okay. So the middle carbon will have more than 80 electrons surrounded, okay. So that's wrong, okay. So that's something to keep in mind, okay. And sometimes you have to push electron twice, okay, and then get the kind of everyone follow kind of octet rule, okay. Okay, so we'll show you one example, okay. So actually kind of the first situation, okay, electron pair next to pi bond, okay. So this one has to push electron twice, okay, 1, 2, okay. Otherwise, you will break up octet, okay. So other, okay, so probably push electron once, okay. So should be fine, okay. All right, okay. Okay, one example, okay. So all right. So for example, we have this the structure, okay. So we want to draw this kind of Lewis resonance structure, okay. And then we can second lone pair electrons adjacent to pi bond, okay. And then it just push like this way, okay. So if you push once, okay, so that's your generate something like this. So this carbon will surrounded by more than 80 electrons, break up octet rule. That's wrong, okay. So to get the right the resonance structure, okay. So you need push electron twice, okay. So you push these 2 electrons on the pi bond all give to this carbon, okay. So that's no problem, okay. This carbon has 1 extra hydrogen, but if you all give to it, okay, so it still follow octet rule. Right, so you push electron twice. Right. And then now the positive charge on oxygen, negative charge on this carbon, okay. Right. So this carbon still surrounded by 80 electrons, okay. So you can draw the full structure, okay. And won't break up octet, okay. So that's something keep in mind, okay. That's also shown here, okay. And so sometimes when you draw the Lewis structure, okay, so draw the resonance structure, okay, so there's a possibility you can get less than 80 electrons. That's fine, okay. So less than 80 electrons is no problem, okay. So give you one example, okay. So so we still use this ketone as example. Okay, so yeah. Right, so pi bond connected by two different two different atoms connected by pi bond. Okay, so you can do fourth kind of shift. Okay, give to the high electronegativity atom. Right, negative charge here, positive charge here. Okay, all right. So after you do this shift, okay, you'll find oxygen still surrounded by 8 electrons, but carbon, okay, so only 6. Okay, so that's fine. Okay, no problem. Okay, this is the right structure. Okay, and in other words, okay, so when you do the resonance structure drawing, okay, so yeah, you can get the less than 8 electron. That's no problem. That's the right structure. Okay, but yeah, if you get more than 8 electron, okay, that will be wrong. Okay, so that's keep in mind. Okay. All right. Okay. So now we come kind of one of the most important kind of the actual kind of most important kind of sentence in this chapter. Okay. Never shift electron to or from carbon with 4 single bond. Okay. Right, so you cannot put electron on the actual carbon with 4 single bond, or kind of take electron away. Okay, and for example, okay, so yeah, we use this guy as example. Okay, just this structure. Okay, right. So yeah, for this terminal carbon, there is the 4 single bond. You can put the hydrogen back. Okay, 4 single bond, 3 CH, 1 CC. Okay, right. So you'll never do this. Okay. That's what will happen. Okay, so some students say, okay, so yeah, how about the way put this shared electrons. Okay, so the pi bond to here. Okay, that will be wrong. Okay, because this carbon will get more than 8 electron, break up octet. Okay, right, so that's don't do that. Okay, right, some students said kind of can we do this? Okay, so we just kind of take this single bond. Okay, so electrons put to here. Okay, so that's also wrong. Okay, because in this case you break up this single bond. Okay, this two carbon no more electron collect. Okay, right. So write it down. Okay, write it down. Okay, right. Carbon with 4 single bond. No resistance. Okay. Carbon with 4 single bond, no resistance. Okay. So that's the one of the most common mistake. Some students kind of randomly shift the electrons. Okay. Try their best luck. Okay. And then okay. If you find carbon with 4 single bond. Okay. Never take electron away from it, and never shift electron to it. Okay. Right. So in future exam quiz, okay, if I find someone, okay, so try to do resonance for the carbon with 4 single bond. Okay, I will minus actual credits. Okay, right, keep in mind. Okay, I will minus actual credit. Okay, so if you do this, okay, so try to take electron away from carbon with single bond. Okay, or put electron onto the carbon with 4 single bond. Okay, right. Right. Okay. So next kind of some student kind of said, okay, in this case, how do I draw the resonance structure? Okay. So here I show you guys kind of tips. Okay. Right. So you just follow the following 2 steps. Okay. Right. Step number 1. Okay. So first find all lone pair electron and all the pi bond. Okay. The pi bond include the double bond. Okay. Or triple bond. And also empty orbital. Okay. Empty p orbital. Okay. Just kind of empty orbital. Okay. Right. So empty orbital. Okay. So normally it's just kind of the atom with the last 8 electrons. Okay. So sometimes kind of this atom is showed as kind of positive charge. Okay. So it's easy to identify. Okay. But sometimes kind of even neutral. Okay. So I will show some example. Okay. So you need to figure out whether this atom has the empty orbital or not. Okay. Right. So that's 3 things. Okay. You need to find. Okay. Lone pair is. Okay. And then pi. empty orbit, okay. Right, and then second, okay, shift electron between the kind of adjacent these three guys, okay. Adjacent of three. The three is kind of these three guys, okay. Right, okay. So what adjacent means, okay? Adjacent again, okay. So connect by a single bond. Right. Okay, so give you guys kind of one example, okay? So this page kind of full thing. What's going on? Okay, it's back. Okay, cool. All right, give you guys kind of one example, okay? So yeah, for example, yeah, we have this kind of the structure, okay? So yeah, quite often in the quiz one exam, okay, ask kind of I give you kind of one structure, okay? Ask you draw all its kind of the resonance structure, okay? All right, so step one, okay, find these three components, okay? So for this case, okay, so yeah, lone pair electrons here, okay, pi bond here, okay, right, and then make sure these two get connected by a single bond, okay? So that's single bond, no problem. You can do the shape, okay? So that's actually kind of pi bond next kind of the lone pair electrons, okay? So we can do the shape like this, okay? Pi bond next to lone pair electrons, okay? So you need a shaped electron twice. Right, so these lone pair electrons now become kind of the pi bond, and then this pi bond become kind of lone pair electrons on the terminal carbon, okay? Right, keep in mind, track here the post formal charge change, okay? So original nitrogen kind of neutral, okay, but now you have to give out kind of one electron share with this carbon, okay? So now become positive charge, okay? This carbon original neutral, okay, but now you give a pair of the lone pair electrons, okay, become the negative, okay? Right, so fine, okay. Right, keep in mind, okay, and so yeah, if you have two component kind of connect kind of in different ways, okay, so yeah, you cannot kind of do the shift only by single bond adjacent, okay, so that's keyword here, okay, so yeah, highlight, okay, single bond, okay, all right, so give one example, okay, so for example, yeah. Right. Okay, so we have the lone pair electrons on these terminal carbons and pi bond here, okay. But these two guys connect by two single bond, okay. So that's not adjacent anymore, okay. No resonance structure, okay. Right. So too far away, not work. Okay. Too close, also not work.
And wouldn't that middle carbon have 4 single bonds?
Yeah, that's right, okay. That's right, okay. So this one has 4 single bond, never shift electron to it, okay. So that's right, okay. Right. Another example, can too close, okay. Right, so we have lone pair electrons and also pi bond, okay. Someone said, oh, okay, so we can shift the electron. That's wrong, okay. Because this guy not connect to by a single bond, okay. So yeah, not adjacent, okay. That's just on the same atom, okay. So this case, yeah, you cannot do like this, okay. All right, so that's wrong, okay. All right, got it, okay. Has to be connected by single bond adjacent, okay. All right, so that's something to keep in mind, okay. This one doesn't work, okay, so no resonance structure, okay. But second one actually kind of, there's a resonance structure, okay. So that's a pi bond connected by 2 atoms with a different electronegativity, okay. So you can do this shift, okay. That's no problem, okay. That's fine, okay. But here you cannot the shift this lone pair electrons, okay, under this pipe. Yeah. All right, so yeah, now it's you guys take a try, okay. Practice on the 42 questions, okay. And take a try, okay. So first, the pair of questions kind of already showed you the curve arrow, okay. So yeah, and then tell you where the electron start, okay, where the electron go, okay. So you need to draw is kind of resulting resonance structure, okay. So yeah, and then second the question kind of more common you will see in the future exam and the quiz, okay. So I gave you one structure, okay. Ask you kind of draw it's the resonance structure, okay. All right, so take a try. Right. If someone like, okay, so you can also use the annotation the function, okay, so draw your answer on the screen. All right. So for the resonance structure, okay, that's the relatively hard part, okay. So yeah, the better way to start is you need do a lot of practice, okay. So yeah, unfortunately, okay. So. And then you will have some kind of sense, okay. So where's the electron goes, okay, where's the forbidden, okay. So what's kind of the allowed, okay. All right, anyone want to try the first molecule? All right, okay, someone want to try it, good. Okay, I guess that's H, okay. All right, good. All right, good. Okay, so no done yet, no done yet. Perfect, okay. All right, so that's the first one is right, okay. So yeah, now the nitrogen has the positive charge, okay. Pretty good, okay. Anyone want to try the second one? Yeah, the first one is lone pair electrons next to empty p orbital, okay. And the second one is kind of the little bit hard, okay. You push electron twice, okay. So the lone pair electrons next to pi bond, okay. So anyone want to try the next one? What's going on? Yeah, the annotation is kind of on the top, okay. So for me it's on the at the bottom, okay. For you guys probably it's different, okay. So all right, okay. So the carbon has too many bonds. All right, click on undo, okay. Yeah, click on undo, you should be fine. All right, okay, good. All right, so yeah, pretty good, okay. That's right, okay. All right, so you guys did better than the morning lab section, okay. Morning lecture section, okay. All right, so you shape the electron twice, okay. Build up bond between the kind of two carbons, okay. And then nitrogen gain one pair of electrons, okay. And then that's you get kind of a negative charge on nitrogen, okay. Pretty good, okay. All right, okay. So okay, so for the last two questions, okay. So because the time kind of okay. All right, thank you. The two students kind of finish these two questions. Okay, so I have to clean your drawers. Okay. Kind of clean. All right, I don't know why I cannot clean. Okay, anyway, okay. Okay, anyway, okay. So for the bottom two questions, okay, because of time limitation, okay, I just draw the answer, okay. So you have NH2, okay. H. Okay. So again, okay. So first thing you need to do is okay, something ask questions, okay. Why the nitrogen -1, okay? Right, because the original nitrogen is kind of zero formal charge, okay? And then you shift one pair electrons to nitrogen, okay? So nitrogen gain 1 electrons, it become -1, okay? Yeah. I don't know, I cannot. Okay, so something wrong. Okay, now it's clean up. Okay, thank you. Okay, so now we do this one. Okay, so that's the lone pair electrons next to pi bond. Okay, so so remember you need to find all the kind of lone pair electrons, pi bond, empty p orbital. Okay, so this one lone pair electron next to pi bond. Okay, right, you shift here twice. Right, you generate kind of it's a resonance structure. All right, okay, so now you need labeled formal charge. Okay, so original everyone's kind of neutral. Okay, but this one, okay, so nitrogen lose 1 electron, become positive charge, and carbon lose gain 1 electron, become negative charge. Okay, so those you need to label it. Okay, right, and then the last one. Okay, so last one is right. So again, step 1. Okay, so find all the kind of the 3 components. Okay, this one has the empty p orbital. And then pi bond, okay, so that's and then you have to look at, okay, so whether share kind of adjacent to each other, okay, so that's the single bond separate, okay, no problem, you can draw it, okay, so first pi bond kind of the next to empty p orbital, okay, so you can shift like this way, okay, you build up a new pi bond, right, empty p orbital become here, right. And then now this pi bond will be next to empty p orbital, okay, so that you can shift like this. So that means for this the structure you can draw more than one resonance structure. So positive nodes here, okay. All right. Someone asked kind of how about I shift this pi bond to here, okay. And the answer is yes, okay, but that's kind of back to the original structure, okay. So for this one, okay, so that's you totally can draw the 3 resonance structure, okay. So so sometimes kind of last year kind of quiz, okay, so that's one question, okay, you can draw 5 resonance structure, okay, so that's you need a little bit careful, okay, try to draw all the resonance structure, okay. All right, okay, so that's a little bit hard chapter, okay, so we'll do a little bit of practice in the kind of quiz tomorrow, not quiz, okay, so the discussion tomorrow, okay, so don't worry, okay, so and eventually, okay, more practice, you will learn how to draw the resonance structure, okay. Right, so that's pretty much done the class today, okay. All right, anyone has questions? Yeah, thank you. Okay, you're welcome.
Thank you.
Yeah, thank you.
Thank you.
Yeah, thank you.